Next concept is abstraction. 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 What is the general definition of abstraction? What is the general definition? Abstraction. Hiding the implementation. Hiding the implementation. Showing what is necessary. Hiding the implementation. Showing what's necessary. Hiding the implementation. The general definition of abstraction. If anybody wants to join the meeting, please join first. What happens here? I need to admit one by one. Okay, if you are coming, if I'm in the same window, automatically it is going to admit. If I change the window, I need to come here to this window. I need to admit. That is why here abstract is the keyword. Abstract is the keyword. Abstract class A. Abstract class A. Abstract class A. For the class, I can declare abstract keyword. Class I can declare with abstract keyword. Class I can declare with abstract keyword. Now, abstract class can have both implemented or concrete method and also abstract method. See, this is what we are calling concrete method, implemented method, a method with the definition, method defined. They will ask, what is concrete method? Means a method with the body. A method with the body or concrete method, defined method, all are same. Now, abstract class can have both abstract method as well as implemented method or concrete method. Okay. Now, what is abstract method? A method without the body. A method without the body. A method without the body. Without the definition. That method we are declaring it as abstract with the abstract keyword. With the abstract keyword, a method without the body. Abstract class can contain both defined method or concrete method or implemented method and non-implemented method, that is abstract method, a method without a body. Both it can contain. Compilation, check the compilation. Compilation is success. You cannot run, why? Because there is no main method. In one abstract class, you can develop any number of abstract methods. In one abstract class, you can develop in one abstract class, you can develop any number of abstract methods. Any number of abstract methods and any number of concrete methods. Any number of abstract methods, any number of concrete methods. In the class, if I declare any method as abstract, then that the class must be declared as abstract. If I have at least one method as abstract, if I have at least one abstract method, then that the class must be declared as abstract. Here compiled the error. A class can have abstract method also, non-abstract method also. If at least one abstract method is present inside that class, then that class must be declared as abstract. Abstract class can contain both abstract method, non-abstract method. Here we don't have any abstract method, but the class got declared as abstract. No issues at all. Now, if the method doesn't have the body, if the method doesn't have the body, then you should declare that method with the abstract keyword. Then you should declare that method with the abstract keyword, otherwise compile time error. Missing method body or declare as abstract. Give the method body or declare that method as abstract. Abstract methods cannot have the body. Abstract methods cannot have the body. Compiled time error. Abstract methods cannot have a body. Abstract class here. In the F class, I have one abstract method, abstract void test one. I have one concrete method, test two. Class G extends F. Both the methods are inheriting. Both of the methods are inheriting. Test one and test two. Test two got the implementation in the F class itself, but for the test one, there is no implementation. I'm giving the implementation for the test one of the F class in the G class. Okay. Both are inheriting. Test one also, test two also. For the test one, I'm giving the implementation in the G class. Another point here, when you are inheriting, when you are inheriting the abstract methods, you should give the implementation in the subclass. Otherwise, you should keep that class also abstract. You are not giving the implementation or body where you are implementing, where you are inheriting, that class must be declared as abstract. Why? Because that method are not implemented. That is why. If you are giving the implementation, no, there is no need of keeping this class as abstract because I'm giving the implementation. Another point. G cannot able to create the object for abstract class. Abstract class cannot be instantiated. Instantiation means what? Creating the object. Abstract class cannot be instantiated. We cannot able to create the object for the abstract class. We cannot able to create the object for abstract class. Now, in the G class, test 1 and test 2 both are available. By using G1 reference, I can access test 1 also, test 2 also. Simply I'll get what? What I'll get? From test 1, from test 2. Then done. Three abstract methods I have in the H class. I'm inheriting to the I class. H class extending with I class. H class is extending by I class. I class is extending with H class. Okay. Now all these methods are available in the I class. Right or wrong? All these are available in what? I class. I need to give the implementation for all those methods. I need to give the implementation for all those methods. I need to give the definition. I need to make it as concrete. I'm giving the implementation for all those methods. Now there is no necessity of keeping this class as abstract because all the methods are implemented. Whatever I have inherited, all the methods I have implemented. There is no necessity of keeping this class as abstract. Main method. I cannot able to create the object for H class by because it is abstract class. For abstract class, I cannot able to create the object. For the I class, I'm creating the object wherever I'm inheriting. For that class, I'm creating the object. Using that class reference, I'm using those methods. Then done. One, page two, 3. Done. Carefully observe. Two abstract methods, one concrete method. All are inheriting to the K class. Only test one I'm implementing. I'm giving the implementation for only test one. Still, test two is the abstract. Test two is abstract in the class K, right? We are not giving any implementation for test two. Test one and test three got the implementation as of now in the K class. But test two is not having the implementation. So one abstract method is there in the K class. That is why I'm keeping that class as abstract. That is why I'm keeping K class as abstract. Now L extends K. Now I'm giving the body or implementation for test2 here in the L class. All the methods are there in the L class. Test1 also is there, test2 also is there, test3 also is there. For test2, there was no implementation. Now I'm giving the implementation in the L class. Now I don't need to keep this class as abstract. No, not necessary. Creating the objective for L, accessing all the methods. Then done. Declare what? If I declare class L as abstract, I cannot be able to create the object for L later. Cannot able to create the object for L, and you cannot able to access those methods. You need to inherit to the subclass. Like what? Class M extends L. There you should keep the there you should create the object for M class. Like that.
So why should we hide the implementation? So what is the purpose of hiding the implementation?
Yeah, exactly. After this program. What can you understand by this program? One car is there. To make use of that car, it should be used by some person. Car is there. Without using, what is the use now? Car is there. Some person need to use that car. Now, driver will be driving the car. Driver will be driving the car. You should know how to drive. You should have a license, but you should not be a scientist. Right or wrong? Doesn't need to be a scientist. Technical things he doesn't want. You just want what? How to drive, license. In the my driver class, technical things is unnecessary. Okay, technical things is unnecessary. That is why I'm hiding that. But how to drive is important. Driver should know how to drive. In the car class, if I say car, both things needed. Driver also needed. Technical things also needed. If any one is missing, useless. So whatever needed for this class, that only I'm implementing. Which is unnecessary, I'm hiding that. I'm giving the implementation in the subclass. In the car class, I'm giving the implementation for technical things. Car is having how to drive also. Car is having technical things also, right? Here, abstract class K, four methods. Abstract class L extends K. Void method one. I'm giving the implementation in the subclass method one. Still, method 2 is not implemented, 3 is not implemented, 4 is not implemented. One more method, it is from the class L itself, abstract method. This abstract method belongs to this class only. Now, M extends L. For all those methods, I'm giving the implementation in the M class. That is why I'm not keeping this class as abstract. Then creating the object to M class, accessing all the methods.
If we declare all the methods in the upper class only, then no need to give abstract.
If you're having the implementation for all these methods in this class only,
Not there, sir.
here,
L.
yeah, here only. There is no need of keeping this abstract. For this class only you can create the object. We cannot able to create the object for abstract class. We cannot able to create the object for abstract class. Creating the object for O class. Now, O is extending N class. N class is having test one. Using the O reference, I'm accessing test one. Abstract class P, test one. I'm keeping class Q as abstract, but Q is not extending P. R is extending P. R is extending P. I'm not keeping R as abstract. Why? Because there are no abstract methods are there in the class P, abstract class P. S extends R. There are no abstract methods are available in the R class. That is why I'm not keeping the class S as abstract. class D. For P class, I cannot able to create the object, but because it is abstract. For Q class also, I cannot able to create the object, but because it is abstract. For the R class, you can able to create the object and call the test one. R is extending P. Test one will be available in the R. You can create the objective for R, then you can access the test one method. You can create the objective for S and you can access the test one. S is extending R, whatever that got inherited to the R from P class, the same it is inheriting to S class. You can create the object of S class and you can able to access that test one method. Inside the abstract class, can I have the constructor possible? Possible. If I don't create the objective for abstract class, then what is the necessity of keeping this constructor in this class, abstract class? Possible or not? How can you change your mind, man? Like that? Huh? Possible or not? Observe. Possible. Data science experts. Okay. How it is possible? Carefully observe. In the subclass, I'll be having the constructor. In the subclass, in every class, I'll be having the constructor. If I'm inheriting this class, now this becomes the superclass, that becomes the subclass. From the subclass, from the subclass, I can make a call to this constructor. From the subclass constructor, I can make a call to this constructor. I'm not creating the object, but I'm calling the constructor. Possible or not? Exactly. Here, super with no argument. This is calling this constructor. First executing B no argument, then only B, W no argument. Then done. Okay. Here super with no argument will be there or not? That is calling superclass no argument constructor B no argument, then only W no argument, then done. We can have the constructor. What about this? What about this? Abstract method I have test one got inherited, but I'm not implementing. That is why I'm keeping this Y class also abstract. Y extends X. Now I have the constructor. I'm not leaving it for the default super statement. I'm giving the super statement. I'm passing one argument. It is calling the super class constructor, which is taking one int as the argument. Z extends Y. Here I'm giving the implementation for the test one. That is why I'm not keeping the class Z as abstract. Z extends Y. Now here I have the constructor. While creating the object to Z class, super with no argument, calling super with no argument, calling this constructor. It is calling what? Super with argument. Going to the super class constructor, executing x of int, coming back y of no argument, coming back z of no argument. Then only separation. Then obj1 dot test1, it is calling test1, then done.
What is the abstract word?
Hmm?
Abstract word.
There. This one. Now.
Ah,
What is this?
that one.
What is this? What is this? Pakka? Now you understood? What was the confusion for you?
Now I got it.
Earlier, what was your confusion?
What?
What it is? Like that. We have seen 10 examples at least. X extends object. Whether you, what happens here? All the classes are extending object to class, whether you give it or not. Now this Y class also indirectly extending what object to class. But in the Java, multiple inheritance possible. User wise, not possible. But internally, what is happening here? Y is extending object to class. Indirectly, not directly, indirectly. But here, why? Because it is extending X class, right? Or not? It is extending X class. Explicitly not possible. Okay. But indirectly it is extending the object class, every class. You need to run what? Interface. Why do we need the interface? Why do we need the interface? In case of abstract class, it is not 100% abstract. In case of abstract class, we are not achieving 100% abstractness. Why? Because we can have both implemented method also, unimplemented method also. We can have both abstract method also, non-abstract method also. It is not 100% abstract. We cannot able to achieve 100% abstractness in case of what? Abstract class. To achieve 100% abstractness, we are using the interface. By default, interface is abstract. By default, interface is abstract. Whether you give it or not. Abstract keyword is optional. If you are giving, no issues at all. By default, interface is abstract. To achieve 100% abstractness, we'll be using the interface. By default, interface variables are public, static, final. By default, interface variables are public, static, final. Public, static, final. By default, interface variables are public, static, final. By default, interface methods are public and abstract. Public and abstract. You cannot have a concrete method inside the interface. You cannot have a you cannot develop a concrete method inside the interface. There should be only abstract methods, not the implemented methods. Only abstract methods. Here, one more point. If anything, if any variable, if I declare it as final, that value, that variable should get a value. Okay. That means what? If a variable declared as final, if I supply value, then that is fixed. We cannot able to change. We cannot able to change the value of that variable further. That is constant, fixed. One more point here. Interface methods are not final. Okay, whatever the methods I'm giving here, those are not final. If it is final, no, I cannot able to override those methods in the subclass. Only variables are final. Class is also a Java file member. Abstract class also a Java file member. Interface also a Java file member. For all these members, compiler will be generating the value. Leader class, leader class, leader class. And by default, interface methods are public. We are going for protected. What happens? Modifier protected not allowed here. Private also not allowed. Private also not. Why I'm keeping this as public? Because I can give the implementation in the subclass. If you are not giving anything, by default it is public. By default it is public. Interface. Interface members. Interface methods will be by default abstract only. Okay. I don't need to specify it as abstract. If you are giving the method inside the interface that is without body only, means you don't need to keep the abstract keyword here for the method explicitly.
Why should we give a public keyword abstract?
Why should we keep the public for?
You said that like all the methods in the interface are defaultly public as well. Yeah, you should specify them as public. So.
If you don't specify, it is public itself. If you are specifying also no issues. They are explicitly specifying public, no issues. If you don't specify, that is public only. If you are going to specify, only you can specify public. Other than public, you cannot specify anything. Protected, you cannot. Private, you cannot. Okay? Now, by default, these are the abstract methods. You don't need to keep the abstract keyword here. Now I'm keeping the abstract. No issues at all. Keep it or leave it. Interface methods cannot have a body. It can only contain abstract methods, not the concrete methods. Can I have the constructor? Possible? Why not possible?
Because interface is abstract.
So,
So there should be no body.
okay, what happens in case of abstract class, we can have a method with the body and without the body also. But in interface, compulsory method should be not having any body. Constructor is what? Implemented, right? It is having a body, concrete, not possible. Internally, it is going to consider constructor also a type of method, not method. Don't get confusion. It is not a method. No. This the constructor is different, method is different. Now it is the you can consider a block, implemented block, not possible. AAB also not possible, static also. IAB also not possible, SIB also not possible. Interface N, public void test 1. In case of interface, class to interface, it is implements class to interface. Implements. Class O implementing N interface. Class to class, that is extends. Interface to interface, that is extends. Class to class extends. Interface to interface extends. Class to interface, interface to class, interface to class, interface to class. Extend. Interface something extends some class. Okay. O implements N. I'm giving the body in the N class. I'm overriding the test upon the method of the N interface in the O class. I'm giving the body. Here, you can only go for public while implementing. You can only go for public, not the protected or not the private, or not even. If you give like this, no, what happens after? Pass public. Here, assigning the beaker access privileges, it was public. Now I'm giving the default. Public is the wider access or stronger access, means wider. Here, less than the public, it is a narrow one or weaker, narrow one, narrow access. Public is the wider access, anywhere you can use. Before that, narrower, weaker one. Now that is why here public is there. If you are not giving it also, assigning, trying to assign the weaker access. Whether you give it or not, that is public only. By default, it is abstract. No, no issues at all.
Why it is showing error, sir? Not public.
Huh?
Public is not going to be showing error.
Yeah, if public is not given, yeah, by default it is public. No, that is why. I don't give anything.
It is correct on public. By default, it is public.
Of course, by default it is public. Here, What is this? It is a class, no, it is not interface. Right or wrong? By default, it is not public. It is what? Default. That is what. Okay. This one now. This one now. Here, class O, what I said, interface methods are public by default. But class methods are not public by default. So here, keep the abstract public or public abstract. Functions. Both are same. Here, you can only go for public compulsory.
Also, you know, the public interface of abstract object and
Remove this abstract public. Same thing. No issues at all.
error not compulsory.
No error. I'm not able to create the object for n. For interface also, I cannot able to create the object interface. Cannot be instantiated. You cannot able to create the object for interface. But I can create the reference variable, not creating the object. Creating what? Reference variable. N type of reference variable, name is int. For the reference variable, I can supply null. I cannot able to create the object, but I can able to create the reference. For the reference, I can supply the null value. Creating the O class object, calling the test one.
Also, you can create
Here, test one. Why do test one? Why do test two? Both are public and abstract. Implements B. Q implements B. Test one. Test two. Why you are overriding in the subclass? Method signature should be same. Test one doesn't take any argument. Test two takes one int as argument. That only I'm implementing. Overriding. We'll come to know what is overloading and overriding. Creating the object for Q, calling test one and calling test two. While calling test two, you should supply one value. Okay. From test one, from test two, done. interface R contains test 1 and test 2. For test 1, I'm giving the implementation in the S class. For the test 2, I'm not giving. That is why I'm keeping class as abstract. T extensions. Now, for the test 2, I'm giving the implementation in the T class. That is why I'm not keeping class T as abstract. Then creating the object to T. Then calling the test 1. Here in the SOP, I'm calling test 2. Test 2 method will be called as well as return value will be printed. If you simply call like this, what happens? Method will execute, that's it. But return value won't be printed. If you are calling the method inside the SOP, what happens? Method is calling as well as return value also printed. Interface U, three methods. Test 2 I'm implementing, but remaining what? Test 1 and test 3 not implementing, that is why I'm keeping abstract. Test 1 I'm implementing, but still test 3 is not implementing, that is why I'm keeping this class as abstract. Now, this class contains its own abstract method called test 4. X extends W. Now, I'm giving the implementation for test 3 and also for this test 4 in the X class, that is why I'm not keeping this X class as abstract. Now, in the main method, creating the object to X class, calling test 1, test 2, test 4. Now, observe here one more thing. For the test 1, should not supply any value, right? For the test 2, you should supply one int value. For the test 3, you should supply one boolean value. For the test 4, you should not supply any value. While calling the test 3, I'm supplying the boolean value. Test 3 will be executed as well as the return value will be printed. What is the return value? What is the return value? Boolean. Here, B it is going to return whatever I'm sending while calling. That only is returning. True is returning. True will be printed. Interface X int I. Compilation success. Hmm? What? Observe. What that means. Interface cannot have a constructor. There won't be any default constructor. Compiler also won't be keeping any constructor. Why? Because it is interface. Case of class only, it is keeping the constructor. Now, this int I is final. This int I is final. If it is final, where is the value? I is not getting the value. I is not getting the value. I doesn't have the value. If there is a constructor, there might be a chance of initializing this variable in the constructor. But here, there is no possibility of having constructor. And it is final. If final is there, wherever you are declaring now. So here in this case, we should supply the value in interface. Should supply the value. If it is final, you should get the value. Any value, any value. Now it is fine. You know this already. What happens?
Or we should not do it.
In the interface, we cannot have any implemented methods. Can I have like this? Possible, huh? Perfectly possible. Syntactically proper. Now, multiple inheritance explicitly is not possible in case of Java, but we can achieve the feature by using interfaces. How? One class can implement multiple interfaces at the same time. Interface A, interface B implements A, comma B, using comma as a separator, implements A, comma B. Okay, that is possible through interfaces. So we can implement any number of interfaces, not only one, not only two, any number of interfaces. class can implement any number of interfaces by using comma as a separator. Even abstract class also implement the interface. Here, class K implements Hij, giving the implementation for test2. Remaining methods are there, test3 and test1. That is one keeping this as abstract. L is extending K. Test1 and test3 got implemented in the L class. That is why I'm not keeping this class as abstract. Running log into L, calling all these three methods. Can one class extend multiple classes? Not possible. Not possible. But multi-level inheritance is possible. Multi-level is possible, not multiple. Multi-level is possible. What is that multi-level? Class B. Q extends P. R extends Q. S extends R. One class at a time. You can extend the class and implement the interface also. Class W extends U. Why? Because use the class. Then implement V. Right? A class can extend and also implement. Possible? Extending one class, implementing multiple interfaces. One class can extend only one class, but can implement any number of interfaces. What happens in this case? If, if you want to extend and implement, simultaneously, then you should go for what? First, you should go for extends, then only implements, not implements, then extends. No. The order should be first extends, then only implements. A, B, C. Now, C is the abstract class. D extends the abstract class C, implements the interfaces A and B. I'm giving the implementation for test 1 and test 2 as well as test 3. Test 1 and test 2 are the methods of the interfaces. Test 3 is the method of abstract class C. Now, method test 4 got the implementation in the C class itself, creating the object to D, calling all the methods. Understood? Carefully observe. Here, class G extending F, implementing E. In the F class, test 1 already got the implementation. But in the E interface, test 1 is abstract. Both are inheriting to what? G class. While inheriting. While inheriting. Whatever the test 1 is there in the interface, that is getting the implementation through F class test 1 method. Okay. That is why I'm not keeping this G as abstract. Test 1 got the implementation. Test 1 method of the interface got the implementation through the method of F class. Why? Because G is extending F as well as E. F member also inheriting, E member also inheriting. Now one of the member got the implementation, and here method name also same, signature also same. That is why. That is why it is considering this test 1 as implemented inside the G. Assume. Here I have protected. Test 1 in F cannot implement test 1 in E. Right? Private also cannot. Only you can go for public. Compulsory it should be public. If you don't give no error. Compulsory. Nothing that here I have the int. Same method return type, same method main, and what? Same access specifier. Simple. Two methods in the I class. Test one is there. In the J class, compulsory you should give the test two implementation. Test one is already there. Why? Because J is extending what? J is extending what? I. Test one is already there here. Implemented. I class test one method is already there in the J class. Test two. For the test two, I need to give the implementation. Giving the implementation. Then creating the object, calling the test one test. In the J class, it is using a test one implemented method. J extends I, implements a H. Both the methods will be inherited to here. Here. From I class, this member will be inherited to J. Now, test one, we don't need to give the implementation. Why? Because already their implementation is there. That is only we have inherited. But a test two, we don't have the implementation. That is why I'm giving the implementation. Assume here you have the implementation. There is no necessity of giving the implementation in the J class. Now, possible. There is no member itself in the I. Whatever it is inheriting from the interface H, both are giving the implementation. Test to do is not there, assume. I'm giving the implementation is the I. Possible. This is only relating to here. Now it got the implementation. Test one also is there, test two also is there. From interface to class. What is this? Not interface to class. Interface to interface. Okay. Interface to interface it is extends. Interface to interface it is extends. Not the implements. Extends. Interface to interface extends. Class to class extends. Class to interface implements interface to class extends. L extends K. Now in the L interface, both test1 and test2 will be available. Both that inherited to M class. I'm giving implementation for both the methods in the M class. While in M class object, one interface can extend any number of interfaces, but one class can only extend the one class. Simple. Just we have made it lengthy. Interface R, interface S, interface T extends S comma R. Interface U, class D. W class extends D, implements P and U. Both are interfaces. P and U both are interfaces. Whichever the methods are not implemented, for those methods I'm giving the implementation. Test 1 is not, test 2 is not, test 3 is not, test 4 is not. So test 2, test 3, test 4 I'm giving implementation. Test 5 is already implemented in the V class. In V class, test 5 is already implemented. Possible or not? Abstract class X. Value test 1. Y extends X. Giving the implementation. While giving the implementation of passing one argument, possible X. I cannot override the test 1 of the X class. Okay? Why? Because it should be same argument. Now argument is different, not possible. Argument should be same. Return type also should be time same. Argument and return type both should be same, and the name also should be same. So this is all about abstract and interface. Abstract and interface. Now we'll move on to overloading and overriding. What is overloading? Overloading. Overloading is also called as compile time polymorphism. Compile time polymorphism. Overloading. What are the rules to be followed while achieving the overloading? Method name should be same. Argument can be different. Method name should be same. Signature can be different. Method name should be same. Signature can be different. And the return type also can be different. The return type also can be different. Same method name, different number of arguments, and the same return type. Sorry, different return type. Any return type. No issues at all. Earlier, it was non-static. Now it is static. In case of non-static, you need to create the object to access those methods. In case of static, either you can create the object or you can use these methods by using the class reference. Possible. You can create the object, okay, by using object creation also you can access. By using class reference also you can access. This is what we are calling overriding. Same method name, same signature, same return type in the subclass, not in the same class. We cannot able to achieve overriding in the same class. Overriding you can only achieve through subclass. Same method name, same signature, same return type. That is what we are calling overriding. Creating the D class object, calling the test one. Which method it will be called? From test one D or from test one C? Carefully observe. Very important. For whichever the class you are creating the object, for whichever the class you are creating the object, and by using which class reference you are trying to access method, that method will be executed. That method will be executed. Now here, C class object I'm creating, but the object in this case carefully observe both are non-static. Both are non-static. Both the methods are non-static. Creating the reference of C type, I'm assigning the D object, calling the test one by using the C1 reference. Compile and run. Ready? In case of non-static, for whichever the class you are getting the object, that matters. In case of non-static methods, whichever the class you are creating the object, that matters. That class method will be executed. Even though reference is of type super type, super class type, then object is of what type? Subtype. Subtype. Now, because of both the methods are non-static, for whichever the class you are getting the object, that the class method will be executed. But in case of static, carefully observe. Creating the object to F class, by using F1 reference, I'm calling it S1. Which method it will be called? Answer here. Object is F, but reference is E. Both are static methods. In case of static methods, a reference matters. Reference matters. In case of non-static methods, object for which class we are getting object that matters. So static members are not involving in polymorphism. Okay? Static methods. Static methods are not involving in polymorphism. Static methods are not involving in polymorphism. Overriding is the example for runtime polymorphism. Overriding is the example for runtime polymorphism. Overloading is the example for compile time polymorphism. What happens now? Compilation success or not? Hmm? What happens? What happens? Hmm? Ah, return type. In case of overwriting, return type should be same. In case of overriding, return type should be same. Must be same. Now all these are static overloaded methods. Static overloaded methods of I class. Static overloaded methods of I class. By using object also you can call, or by using class reference also you can call. No issues at all. Static void test one. Static void test one. Argument is different. Argument is different. Return type is same. Both are static methods. J class object I'm creating, and I'm calling the test one method of the J class by passing 10 as the argument. Possible or not? J class object. Test one I'm calling by supplying the 10 as the argument. Possible or not? Possible or not? Huh? From which class I'll be getting? From h1.k or from test1.eg. Which class? Hmm? What is happening here? Static methods. Static methods. What is happening? Now this comes under overloading. Overloading. Test one of the J class is inheriting to what? K. Reading the K class object, calling the test one method. Both I can call, observe here. If you call test one, what happens? Carefully observe. Now there is a twist. What can you understand by this? It comes under overloading. This method is inheriting to this K class. Now both the methods are available in the K class, both static. Overloading is what we are calling overloading, not overriding. Overloading. Both the methods are available in the K class. Whichever the method you want, that method you can call. Creating the J class object. Sorry, creating the J class reference. Creating the K class object. Now these two are both the static methods. Which method it is going to execute? Hmm? They are getting here. J class reference, K class object. In this case, reference matters. Reference matters. Now in this J class, test1 is accepting one int as argument. I should submit that argument, then only I can call. I know. So all these scenarios you should understand. Here, what is happening? What is happening? Overloading or not? This method is inheriting to M class. Both you can call. Huh? N class reference, O class object. We will be executing this one because of static. Return type is different to extent to B. Under what? Overloading. Both are static methods. S to one. S to one. I'm trying to override. Which method it will be invoked? Directly I'm calling test one. Directly I'm calling test one. Both are from the yes. While calling the test to one directly, it is considering its own static method. Yes class has its own static method, test one. Static, it is something that belongs to this yes class. Test one is we have, okay. Even though it is extending R, if I directly call the test one, it will be yes class. If you want the test one of R, fine. Overloading. In case of overloading, method return type can be different and the argument also can be different. What happens? Error, right? Why error? Overloading. Perfect to overloading. We have two options. I'm using what? Creating the object, then calling the test one, test one. This one, overloaded methods. But in class name also you can call, no issues at all. Okay. So this is all about overloading and overreading. Shall I continue? Next concept is typecasting. Vinay MS.
Yes, sir. Sir, yesterday class also present, sir.
See, Arshita. Chaitra.
Present, sir.
Baswaraj. Madesha HP.
Yes, sir.
Kiran R. Syed Afsar. Syed Afsar Pasha Quadri. Chanapa. Spurti. Kirtana. Nishita Prakash. Chandan K. Nandish Babu.
Yes, sir.
Ram Kumar. Rakshit Kumar.
Present, sir.
Anil Kumar.
Present, sir.
Anil Kumar.
Present, sir.
Ankit Gar. Ankit Gar. Vaishnavi Hegde. Vaishnavi Hegde. Pritam BR. Gagandeep. Salma Taj.
Present, sir.
Tarun Singh. Abhishek Singh.
Present, sir.
Gagan Gosavi.
Yes, sir.
Ahmad Omar. Ahmad Omar. Deepthi SH. Shruti R. Chandana M. Yamuna M. Harish D. Harish D. Chetan M. Shalini.
Present, sir.
Kamala.
Present, sir. Present, sir. Kamala.
Shalini.
Shalini also present, sir.
Yashaswini NR. Samay Zuma.
Present, sir.
Shreyas. Shreyas. Darshan S.
Present, sir.
Fine. We'll continue in the next class. Thank you.